Today is the day for non-parametric test, and today I will cover some of the non-parametric tests because time is limited. So whatever test I will cover. So let's see. Before going to start, I just want to ask that whether am I audible? You can see me.
Yes, sir. You are audible, sir. No problem.
Okay. So
It's
actually,
perfectly
I
fine.
have to check some of the things before going to start. Yeah, volume is fine and everything is fine. Good. So it is 10:29. So 1 minute to go. Surajit,
Yes, sir.
okay, everything is fine.
Yes, yes. Everything is fine, sir. It's perfectly fine,
Great.
sir. No problem.
So you have participant from which area?
Sir,
The participants are from which region?
all the participants are from Assam, sir.
Okay, okay, great. Okay. Uh, so today we are going to discuss the chi-square test first. Then we will go to Mann-Whitney test. Then we will go to Wilcoxon's, and then Fradway and ANOVA. So these four tests I have to complete today. So now I'm going to start the chi-square test, and after the chi-square test, we will discuss the different non-parametric tests. All these tests are non-parametric. Okay. So let me start, and this is the whiteboard which is provided by the Zoom. So there are two types of tests actually. One is called parametric test, and second is called non-parametric test. So this is parametric and this is non-parametric. And the difference between parametric test and non-parametric test is that, number one, in parametric test, there are few differences. Number one, the most important is normal distribution here. So your variables should be normally distributed. And second, it is distribution free. Distribution free test. If your variables are normally distributed, it is called parametric. And if your variables are distribution free, no normal distribution, it is called non-parametric. Number two, large samples and here you can work on the small samples. Non-parametric test will be applicable on the small samples also. And parametric, we require small samples. So if you have sample size less than 30, you can go for non-parametric test. And in case of large samples, if they are normally distributed, you can apply the parametric test. Third case, that is called homogeneity of variance. Homogeneity of variance. Homogeneity of variance means the variance of the two samples, this is group 1, is equal to the variance of the group 2. So we have seen in the t-test and ANOVA test that if this condition is also required, and here it is not required. the homogeneity of the variance is not required. Number 4, actually all the conditions are not very important, like randomness, random selection of the participants. So here it is not random selection of the participants. So basically these are the different, one more important, which is important. Mostly scale variables are involved in the parametric test. And in this case, non-parametric test, most of these tests required nominal or ordinal variables. Ordinal variables. So you can see that most of the non-parametric test we will apply on the nominal or ordinal variables. So this is the difference between the parametric and the non-parametric. So I hope it is clear. And so what non-parametric tests we are going to apply? What are the different non-parametric tests available? So I'm just telling you the list of these. Number 1, we are going to apply, number 1, the chi-square test, which is known as king of non-parametric test. Number 2, I'm going to apply the Mann-Whitney test, which is a very famous Mann-Whitney test. And then we are having Kruskal-Wallis test, non-parametric test, and the last is the Friedman-ANOVA. So these are the 4 famous non-parametric tests that we are going to study today. So I start with chi-square test, and then I will discuss other 4 tests also. Okay, so what is chi-square test? So some brief, I am telling you information. The chi-square test, as I told you today, is analyzing the association between the 2 nominal variables. Nominal and nominal. Nominal variable 1 and nominal variable 2. Nominal variable 1 and nominal variable 2. These are the 2 different variables, and we are interested in finding out the relationship between them. So we are interested in finding out the relationship between them. Relationship is known as association. And we have to find out 2 things in this association, whether this association is significant or it is insignificant. And second thing which we have to analyze is the strength of association. Strength of, so we have to analyze the strength of association as well as whether it is significant or insignificant. So significant and insignificant can we find out 2 things. One is the Pearson chi-square statistic, Pearson chi-square and its p-value. And the strength of the association is analyzed by a test called Kramer's V test. So this is the basic idea about the chi-square. So I just repeat, what is chi-square? Chi-square is analyzing the relationship between the 2 variables, one nominal variable and another nominal variable. and this relationship is known as association, and this association is measured by two things: one, whether it is significant or insignificant, and second thing which we have to find out what is the strength of the association. And whether it is significant or not can be identified by the Pearson chi-square test, and the strength of association is identified Kramer-V. Okay, so now how the chi-square will work? Let's see. Suppose uh, in chi-square we make this table. So let me explain this table to you. Suppose this is X variable, like we are having the gender here, and male and female, and we are having there some variable here, variable Y, and this is the Y1, Y2 and Y3. Like for example, education. If I take education, so this is BSc, this is BCom, and this is BA. So we suppose we want to find out, is there any relationship between the gender and the type of degree? So we can make this kind of table, and this table will indicate you what, that suppose there are 30 males and 30 females in the group. Out of 30, 2 are in BSc, and 15 is in BCom, and 13 in BA. And in 30, we are having female like 10, 5, 15. So this is the actual observation that we have, and then we take the total of this. That there are 12 people who are who did BSc, and 20 did BCom, and 27. This is 28. Is this right? And the sum total of them is 60. So this table is known as contingency table. Contingency table. And from this table, we apply the value of chi-square, and find out the p-value of the chi-square. So I'm not going to the mathematical part of chi-square. I'm just showing you with the help of some example, and which the example will make you clear that what is about chi-square test. Okay, so I'm going to open the file, Spss file. We'll try to explain you with the help of some examples. So I am going to open the Spss file. It will take hardly 1 minute. Yeah. So I hope you can see the Spss file. Yes. So this is the Spss file, and I'm taking the different examples of the chi-square test. Let's open the file, data file. This is non-parametric test and chi-square. Suppose, yeah. So let's start with this example. In this case, we are having two variables, income and the phone, right? So you can see that income is divided into three categories: less than 5 lakh annual income, second category is 5 to 10 lakh, and 3 is more than 10 lakh. And the third category is 1 means budget phone, 2 means mid-segment phone, 3 means flagship phone. So there are 3 type of phones, and there are 3 type of income. And you can see that all the variables are nominal variable. And here the research question is that, just let me explain you that question. We are going to solve this question. So is the type of phone held by customer depends on his her income or not. So we will have this question, this research question, and the hypothesis, null hypothesis, we can make like this. There, so whenever you write the hypothesis, the language should be same. There exists no significant association between, it is a null hypothesis, so I write no significant association between the type of phone and the income level and the level of income. So this is the null hypothesis in chi-square test, and how to solve it, I am going to show the process. So I hope you now you understand that what we are going to do in this example. Okay, so let me apply this chi-square. So you can see the commands: analyze descriptive statistics, and you can go for a cross tabulation, and in cross tabulation, income you can send in the row, and phone type you can see in the column. So row will come into the income, and column will have the phone type. So one variable will go to the row and one variable will go to the column. Okay, so let's click on it. This table, which you can see here, representing the contingency table. Like this table is showing you that there are 30 customers have the income of less than 5 lakhs, and then 40 customers having the income 5 to 10 lakhs, and 30 which is having the income more than 10 lakhs. And out of the 100, 30 is having the budget phone, 36 is having the phone type mid segment, and 34 is having the flexi phone. So this is the contingency table we can generate from the chi-square test. But the question is that whether they are associated or not. So I am going to further apply some of the tests here. Like let's go to the cell expected, and in statistics I am applying the chi-square and phi n Kramer V. So I repeat, uh, in statistics I clicked on the chi-square and the phi n Kramer V, and in the cells I click on the observed and the expected. So after selecting these options, I'm just clicking OK. And now let's see the result. The chi-square test is saying that the chi-square value is 21.678 and the p-value is less than 0.05, and the Kramer V is found to be 0.329. So let me explain you how to interpret this example. So as I remind you, in this case, the null hypothesis is that there is no association. There is no association. So first thing which I want to find out, what is the chi-square value and what is the p-value. So chi-square value is found to be 21.678, and the probability value is 0.000. 0.000. So what is the conclusion we can draw here? The conclusion is that the null hypothesis rejected. Null hypothesis is rejected. So this is the conclusion made on the basis of chi-square test and p-value. So it means there is a significant association between, between income and phone type. Now, second conclusion which I have to draw, the second conclusion for which I have to find out the Kramer V, which is found to be 0.329. You can see here. So in Kramer V, there are rule is, what is the rule? Rule is that if it is more than 0.5 or it is less than 0.5. So if it is more than 0.5, it means there exists a strong association, and if the Kramer V is less than 0.05, this is actually 0.05. No, 0.5. Sorry. It is 0.5. Then we call it moderate association. Moderate association. So there are only two categories on the basis of the chi-square: the Kramer V and the chi-square. In Kramer V, you have to check whether the association is strong or moderate. In chi-square, you have to find out whether the association is there or association is not there. So this is the most important conclusion we can draw from the chi-square. And I will explain you one more thing. After deciding the association, we have to find out the association exactly. So let me clear this. And now we will go back to the here. And here I have to find out the association. So compare. Now in this case, compare the actual and observed. So observed, not expected. We call it expected. Actual and expected. Now let's see budget phone. Budget phone you can see here, and mid phone, flagship phone. In flagship phone you can see the difference actually here, and in budget phone, mid segment phone, this is the difference. Now what we can see on the basis of this, so I think this is I made wrong selection. It is 20 and 14, and it is 19 and 10. So here you can see that the budget phone is found to be higher in case of income less than 5 lakhs, more than expected. 15 is expected. Expected is 9 and actual is 15. So you can see expected is 9. So it is expected that only 9 people should have the budget phone, but actually 15 people is found to have this phone. So we can say the budget phone is found to be in case of less than 5 lakh, more than expected. So we have to find out where the actual is more than expected. So I'm writing here, found where actual is more than expected. Found where actual is more than expected. Right. So this is the answer. We can find out, like for example, if you see the flagship phone, which is costly phone, it is found to be more than expected in case of income more than 10 lakh. And the mid segment is found to be more than in case of this. So the conclusion you can make, so you can make the conclusion like the flagship phone is found to be in case, budget phone in this case, mid seg phone in this case. So this is the example of chi-square test, and I would like to know whether you are getting the concept of chi-square or not, and so that I can discuss example number 2. I just want to see your feedback whether you are getting it or not. Okay, so I will explain you with the help of one more example. I am taking one more example so that it will be clear. Uh, Maybe I will come back on this example again. So I'm going to open the file, one more file, and we'll come back to this file again if it is not clear. Like okay, in this example, the employees of a company are divided into two groups. The first group is sent to health camps, and the second group is sent to awareness lectures. So the employee of a company are divided into two different groups. The first group is sent to the health camps, and second group is sent to the awareness lectures. And the second case is improvement. Yes means they will feel improvement after attending the session, and no means they don't feel any improvement. Now what we want to see here, we want to see is there any relationship between the type of the camp and their improvement or not. So you can see that we are having two variables, treatment, and we are having two type of treatment, health camp and the improvement in the lectures. So just see, there are two type of treatment. One is health camps and the awareness lecture. And did they improve? 0 means yes and 1 means no. Okay, now I want to see, is there any relationship between the two or not? So go to analyze and descriptive, cross tab, this is the command, and type of treatment we are sending to the row, improvement to the column. In statistics, I will click on the chi-square and phi Kramer V, and in cells I will compare observed means actual and expected. Continue and okay. Now first of all I have to find out the value of chi-square. Chi-square value is 25, which is significant. So it means there is a significant association between the improvement and the treatment. Because the probability value of chi-square is less than 0.05. So we can say there exists significant association between the type of treatment and the type of improvement. Now the strength of the association you can see from here is moderate. The Kramer V will tell you whether the association is significant or not. In this case, you can see the value of phi and Kramer are equal. Actually, phi value is applicable only when you are having two categories in the X and two categories in the Y. In that case, you can see the phi value, but actually the phi value is always equal to Kramer V. So you can ignore phi value always and see only the Kramer value. And now because association we find out, so we have to find out where is the association. In health camp, expected is 14, but actual improvement is 28. So we can say that the improvement as a result of health camp is very high as compared to the expected. So actual improvement is more than the expected. In case of awareness lecture, the expected is 61 and actual is 48. So we can say there the improvement is less than the expected. So what conclusion we can draw from here? That health camp is more beneficial for the treatment, right, for the improvement, as compared to awareness lectures. So I hope you have some idea that what we are doing in Chi-square, we are comparing the expected and the actual, and where actual is more than expected, it means treatment is ready to the improvement for health camp. Okay. Now I will show you one more example in Chi-square test, and so I'm looking at your queries. Some of the queries are interesting. Let me answer them. Um, Deepika Das is asking what should be the p-value to reject the null hypothesis. The p-value you can see here, the probability value. This p-value should be less than 0.05. The p-value should be less than 0.05 to reject the null hypothesis. I hope you understand it. And Vinod is asking what is the role of phi and Kramer. I think you are talking about the phi and Kramer. So actually the answer I am writing here. Okay. Basically the phi value is applicable only in 2 by 2 table, and Kramer is applicable for all, right? So you can see that the phi is applicable only 2 by 2 table when you are having two subcategories in X and two subcategories in Y, and Kramer value is applicable for all. So that's why we only report Kramer V. We will not report the phi. This is, I hope you understand this. Uh, Therefore, in all the papers, you can see the value of Kramer V rather seeing the value of phi. Okay. Now, I'm taking one more example so that you can see the command in Spss also. Okay. Surabhi is asking, sir, it is possible to use Chi-square test in some cases as parametric test? No. Surabhi, the Chi-square test is entirely non-parametric test. It is a non-parametric test. Chi-square distribution you can use in some of the parametric tests, but Chi-square test. So there are two things: Chi-square distribution and Chi-square test. So Chi-square distribution you can see in some of the parametric tests, but Chi-square test is non-parametric itself. So I hope your queries are answered. I'm moving to the example, some more example, so that we can have more clarity on the chi-square. Okay, let me open some more data set. Okay, so here, like you can see that performance is divided into three categories: best performance, average performance, and poor performance. And there are three experiments. Like in teaching, we do three experiment: case teaching, blackboard teaching, PPT teaching, and we want to see where the feedback is high. So there are three experiments in the company, and the three experiments are done to achieve the objective. And where we are interested in finding out that which experiment is giving you the best performance. So performance is divided into three parts: performance A, best performance, average performance, and the poor performance. So we are interested in finding out the relationship between the experiment and the performance. Let's see the command: analyze, descriptive, and crosstab. So remember this command: analyze, descriptive, and crosstab. Experiment you can send to the row. Phone performance you can send in the column. So here one thing we should check, that impact should come on the performance to the experiment or experiment to the performance. So this relationship we have to find out. So here we assume that performance depends upon the experiment, not experiment depend upon the performance. So one is independent and one is dependent. So you have to think like this. Okay. So just give me 1 minute and I'm coming back. So I hope you understand that what is independent and what is dependent. And then go to the statistics. We click on the chi-square test and we click on the phi and Kramer V. Then we go to the cells and we can click on the observed and the expected. Click continue. And I think all command we have given. So click on the OK. So first thing we need to check the chi-square value. The chi-square value is 22 and probability value is 0.000. And then we have Kramer value which is 0.352, which is indicating the moderate strength between the two variables. So they are moderately strong. The association is moderately strong. Chi-square is significant. Association is moderate. Now I have to check where the association. So we have to check best performance first. So best performance where actual is more than expected. Actual is 20, expected is 11. So we can see that best performance is actually high than expected in case of experiment 1. In experiment 2, it is more or less same. So 10 and 11 are almost same. And in third case, best performance is very poor, less than expected. It is significantly less than expected. So conclusion is that experiment 1 is associated to the best performance. Experiment 1 is associated to the best performance. Okay, poor performance. So where the performance is poor, in experiment 3, the expected is 9.3, it is 15. So experiment 3 is giving the poor performance, and in experiment 2 it is more or less equal. It is also less. Okay, so here we can see that high poor performance is found to be experiment 3. So in this way, we can find out what kind of relationship exists between the performance and the experiment. I hope you understand this. And we have discussed 3 examples of chi-square test, and I will share my notes with you. So if you go through these notes, you will have more clarity. Okay. After that, I am moving to the second test of non-parametric test. This is called Mann-Whitney test. So if you have any query still with the chi-square test, you can ask. Then otherwise, we can go to the test number 2, that is called Mann-Whitney test. Okay. So can we proceed with the Mann-Whitney test? Now I'm moving to the Mann-Whitney test, and give me 1 minute to open the data and Okay, so the second test which I am going to explain is the non-parametric test. So first test that I am going to explain is known as Mann-Whitney test. Number one, uh, there are two tests actually in this category, Mann-Whitney test, or there is one more test which is the substitute of Mann-Whitney test, is called Wilcoxon test. Now you have to understand that where we can apply Mann-Whitney test and Wilcoxon test. Number one, it is a substitute of t-test. It is a substitute of t-test. Number two, applied for small samples, and it is based on ranks. So this is the concept of Mann-Whitney test and Wilcoxon test. So three things you need to remember: that if your sample size is less and you cannot apply t-test because of this limitation, then you can go to Mann-Whitney test, and the t-test is based on the mean and this test is based on the ranks, right? So let me explain you the concept of Mann-Whitney test with the help of Spss test, and after that we will see how we can run the Mann-Whitney. And okay, so let me open the file for Mann-Whitney first. Open the data of Chi-square. After Chi-square, we are having a test called Mann-Whitney test. You can see here, and let me open this Mann-Whitney. Okay. So in this case, the doctor taking the measure of depression on Monday, and he take the measure on Saturday. And what happens? The data is divided into two groups. You can see that the medicine is given to the patient, six patients. You can see that there are six patients where medicine is provided, and to other six patients, the doctor provides some placebo like glucose and water. So the measurement is taken on the Monday, and the measurement is taken on the Saturday also, right? And in this case, the measurement is of depression. See, what is the level of depression on Monday and what is the depression on Saturday, right? So if I want to apply the t-test here, how to apply? So first of all, I will show you the t-test, and then I will show you the Mann-Whitney test. Suppose I want to apply t-test, how to apply? So I just go to the compare means, independent sample t-test, and I applied Monday and Saturday. There are two variables, and there are two types of treatments. This treatment is medicine and the placebo, right? So this is the requirement for t-test, and let me apply this. So here you can see the results. On Monday, the average depression in the patient group is 24, and the average depression on the other group is 26. On Saturday, the average depression on first group is 14, and average depression on the second group is 21. After that, I have to check whether it is significant or not. So you can see the t value. The t value, okay, this is the f value, is indicating that variance is equal in both the groups, so they are comparable. and we have to check the upper value of t, upper t. So p value here you can see it is more than 0.05. So on Monday the both group have the same depression level, and in the Saturday they are significantly different. And in Saturday the depression of the medicine group is significantly go down, and placebo is not, is higher than the medicine. So what conclusion we can draw from here? The conclusion is that the medicine is having a significant impact in decreasing the depression level of the patient. But in everything is fine here, but there is one problem, that sample size is only 6 and 6. So because of this low sample size, we are not applying the t-test here. We have to apply the Mann-Whitney test. So Mann-Whitney test is a substitute of this test if two conditions are not fulfilled, like if your sample size is low, or if these two value are less than 0.05. In any of these assumption, we can go for a non-parametric test. I repeat, if sample size is less than 30, and if any of the p-value is less than 0.05, then we can go to the non-parametric test called Mann-Whitney. So now I am showing you how we can apply the Mann-Whitney test. So go to analyze. After that, we can go for non-parametric test, legacy dialogues, and two independent samples. So we have to go for two independent samples. So let me apply Mann-Whitney test. Monday and Saturday we will send here, and treatment we will send here. Define groups, they are 1 and 2. 1 and 2. And we are going to apply, you can see that we are going to apply what? Mann-Whitney. And in options, we can click on the descriptive also. Continue and OK. So now, how to interpret Mann-Whitney? It is similar to the t-test, but slight differences there. You can see that there are two Mann-Whitney tests here on Monday, on the Saturday. So on Monday, the p-value, okay, p-value is coming below. Let me open the p-value first. Yeah. So now you can see that the probability value of Mann-Whitney is 0.000. Sorry, where is p-value? Yeah. So the p-value is coming below. This is for Monday and this is for Saturday. On Monday, the probability value is this. On Saturday, probability value is this. So we can say that no difference on Monday and significant difference on Saturday. So it means the medicine is having a significant effect on the improvement. So what happens, I'm just showing you the concept of experimentation. In experimentation, you are having the two groups. This is called group 1 and this is group 2, right? And we measure the depression. So this is O1 and this is O2. O1 is the measurement of the depression for the first group. We call it experiment group, and this group is called control group. In the language of research, the group where you are doing the experimentation is called experiment group. The second group which you keep for comparison is called the control group. After that, you introduce a experiment and again measure it. This is called O3. And here you are doing nothing. And this is control group, and you will measure O4. So here first of all we prove that on this day there is no difference. On initially there should not be any difference, but after providing the experiment there should be the proper difference between the two, so that we can say this X is effective. right? So we want to know whether this experiment is effective or not. So in this case of experiments, where you are using the experiments where you are using some medicine to experiment. In this case, we can apply the Mann-Whitney test. So I hope now you have clarity on the Mann-Whitney test. We can apply Mann-Whitney test in both the cases. Um, we can apply Mann-Whitney as a substitute of t-test if sample size is low and if the distribution is not normal and homogeneity of variance is not there. Right. So let me explain one more example with you of Mann-Whitney, and I hope after that example you will have clarity. Okay. So let me open some more example. Mann-Whitney have okay. No, this we already done. Hmm. In this case, yeah, let me another. Yes, actually, this is also a training example. This is the performance level of the 10 employees before the experiment and after the experiment. So experiment is done on the 10, 20, 10, these 10 people second group. This is group number 2 where experimentation is done. And before experimentation, this is the performance, and this is the performance after experimentation. And here, this is group number, this is basically the control group where no experiment is doing, where no experiment is done. And it is pre-performance, performance before the experiment and after the performance. So we want to check whether the experimentation is useful or not. So if I go to apply the t-test, so we are not going to apply t-test now, just go to apply the Mann-Whitney test. So I request you to repeat, see this command, it's a lengthy command, analyze non-parametric test, legacy dialogues, and then we can go for 2 independent samples. Now we want to compare their performance on the 2 days, and here it is a grouping variable, experimentation and non-experimentation, and I gave the value 1 and 2 here, and after that I'm going to apply the Mann-Whitney test. Okay, and let's see the result. So there is no difference on the first day pre-performance. So you can see that before the experiment there is no difference. P-value of is more than 0.05, but in this case the p-value is less than 0.05. So we can say there is a significant difference between the two. And if I check the experiment and non-experiment in the post-performance, so I can see that the performance is significantly higher as compared to the performance of the no experiment. It means experiment have a significant improvement on the performance. The experiment is having a significant impact on the performance. So this conclusion I can draw from here. Okay. So this is Mann-Whitney test. I hope now you have clarity on the Mann-Whitney test. And now I am going to the Kruskal-Wallis test. The third test we are going to do now, today. So let me go back to the Kruskal-Wallis test. And let's open the Kruskal-Wallis. Okay. So here, there are 4 cities. City 1, City 2, City 3, City 4. Actually, you can imagine that. Let me explain the concept with you. Where Kruskal-Wallis is applicable. Number 1, it is a substitute of ANOVA. Inferior substitute of ANOVA. Inferior or non-parametric substitute of ANOVA. Number two, hypothesis that the mean of all the groups are same, right? So we have to check whether we can do it or not on the basis of p-value. So we will decide whether the groups are different or not on the basis of the probability value. And here in this example, I consider that there is a company, and this company is having showrooms in 4 cities: city 1, city 2, city 3, city 4. And company want to know that, can I say my average sales is same for all the cities? Can we say the average sales of the company in all the 4 cities are same or not? So they collected the sales for 6 days, consecutively 6 days, and find out whether the sales in both the cities are equal or not. So first of all, I will show you the ANOVA test and then I will show you the Kruskal-Wallis test. So if we are having the large data set, then how to apply ANOVA? So in the city is the factor, means category, and sales is a dependent list. And post hoc, we know that we have to apply Tukey test, and options we can apply descriptives. Go. Okay. Now you can see that the F value is found to be significant. It means the average sales in different cities are different. Here it is found that the city 2 is giving you the highest sales and city 4 is giving you the lowest sales. Now you can see the city 3 and city 4 are having the same level of sales, and city 1 and city 2 are having the same level of sales, right? So this is the concept that we can do here. We can check, and same test, because in this case the sample size is very low, only 6. So ANOVA is not applicable. ANOVA is applicable in the large samples. It means we have to apply some other test, inferior test. So now I'm going to apply Kruskal-Wallis test, which is the substitute of ANOVA test. And ANOVA test is not applicable because sample size is very low. So let me go to the Kruskal-Wallis test, and let me show you the command. So it is a K independent samples. So K independent samples, and sales will go to the test variable, city will go to the grouping variable, range we are having the 4 groups here, and I'm going to apply the Kruskal-Wallis test. So Kruskal-Wallis test, what else I require? Descriptive maybe, and click OK. So in this case, the Kruskal-Wallis test is showing you the significant difference. You can see that probability value of Kruskal-Wallis test is less than 0.05. So we can say the groups are not same. And after finding out the mean, we can say that the city 1 and city 2 are having the same mean, and city 3 and city 4 maybe have the same mean rank. Because in ANOVA test we compare the mean, here we compare the rank, mean rank. So this is the difference between ANOVA test and Kruskal-Wallis test. Okay, so let me explain you one more example so that more clarity will have of Kruskal-Wallis test. Yeah, so we can go for this test. Diet. Actually, we cannot apply crystal values on this because we are having no group. Group should be there. Open it. Okay, so here we can actually in crystal values we require so two things. One is the group variable, and second is the consulted variable, skill variable. So here there are two variables. One is income group and whether they are consulted to the doctor or not. So consulted or not, whether they are consulted or not. And income group we are having, there are 3 level of income, 5 level of income, and we want to know whether whether there is a difference between all the groups in terms of how many times they consulted to the doctor, right? So the dependent variable is the dependent variable here, that how many times they consulted to the doctor. Okay, so we want to see whether this times of frequency of consulting the doctor depends upon the income group of not. Okay, so now I am going to apply the first of all ANOVA test here. Income group, go to the factor, and this variable go to the dependent list, and then we can go to the descriptive part, ANOVA post-hoc Tucky test. Okay, so here this is the results, and F test is found to be significant but slightly significant because p value you can see is less than 0.05, but we are having the problem of sample size here. 22 is less than 30, and the software is saying that all more or less you can keep all the groups in one group. Tell me if I let make some changes in the data, because so that I can show you the result actually. Let me show some difference. Okay, now let's see what ANOVA is saying. Compare means one way ANOVA. How many times? Okay, so you can see that now F statistic is going high, and on the basis of this case comparison, we can say that more than 20 lakhs per annum visit the doctor more than the other groups, right? So suppose we want to do this test in coastal valleys, how to do? Now I'm showing you that, and so let's apply the ANOVA in this. Okay, go to analyze, non-parametric test, and then go to the legacy dialogues, then go to the K independent samples, and income group is a grouping variable. Range is 1 to 4. We are having the 4 groups, and how many times should come to the test variable here. and just apply OK. So you have to check the Kruskal-Wallis test. The problem is that Kruskal-Wallis test is saying that all groups are same. The Kruskal-Wallis test is saying that all groups are same. So it is a non-parametric test, but according to the test, there is no difference, as you can see in the probability value. So because in non-parametric tests, they are inferior tests, so they can give you different results. The answer here is that there is no significant difference in terms of all the groups, as p-value is not found to be significant. Okay, so this is the problem that we have in the Kruskal-Wallis. So let me make some data change and let's see what result will come. Sort case, we can do the sorting and let's try to check whether these, so first group, second group and the third group more than 20 lakh. So let me increase this value and see what change will come in the Kruskal-Wallis test. I hope we will have the answer here. Okay, so I make some changes in the data. Let's see what kind of result we are having, whether we are having significant results in the Kruskal-Wallis or not. Now you can see that it is a significant difference. Significant difference is coming, and the mean rank, you can see the mean rank of 15 to 20 lakhs per annum is higher than others. So uh, we are expecting the similar results as ANOVA is also in Kruskal-Wallis test, but the problem is that it is highly dependent upon the sample size. So this is the case of Kruskal-Wallis test. Now I am giving you the condition of example of Friedman ANOVA, that is the fourth type. But before that, I am going to explain you one thing. There is a simple concept in the research which is known as independent samples and the related samples. So let me explain you that concept. The samples can be divided into two categories. The first category is known as independent samples and second samples is known as related samples. Now, what is the difference between independent and related samples? Independent samples are the different, so we can say they are different, mutually exclusive. Mutually exclusive means one person can comes in only one group only, and related samples are means the same samples is there and the same sample is giving you the response 1, feedback 1, feedback 2 and feedback 3. So this is the difference between the independent samples and the related samples. Related sample means the same sample is there. Like for example, if you are taking the feedback of 5 faculty from the same class, this is called a related sample because students are the same. Students are the same, so they are giving feedback to the faculty 1, faculty 2, faculty 3, faculty 4. So whatever faculty teaching them. So this is an example of the related samples. And if we want to check whether the perception of the same sample, same people, right, for different attributes are different or not. So here, if you think we want to check whether the same persons, same group is having different perception for the different attributes or not. So this is the concept of the independent samples and the related samples, right? So now I'm going to explain the ANOVA in case of related sample. Kruskal-Wallis is applicable in case of independent samples, and the Friedman ANOVA is applied on related samples. So let me explain you with the help of some data so that we can understand what is the difference between the different groups. Okay, let me share you the data with you. Spss file. This Spss file open. Open the data for Friedman ANOVA. So now I'm showing you the fourth case of Friedman ANOVA. The Friedman ANOVA, like this is the first case. In the first case, you can see that the same group of people, suppose the faculty teaches them using the blackboard. So what is the feedback? If the teacher teaches with the PPT, what is the feedback? And if the teacher teaches with the case study, what is the feedback? So there are 15 students in the class, and these 15 students giving the feedback for the 3 experiments, blackboards, PPT, and case study. So this is a case of a related sample or repeated sample. It is also known as repeated sample. Repeated sample means the same respondents are giving you the response for the different cases. So this is because this is a case of a repeated sample case or related sample case, and there are more than three or more than 3 groups. So we have to apply the Friedman ANOVA test, right? So now I am going to apply the fourth test, which I call it Friedman ANOVA test. And Friedman ANOVA test is a case of repeated or related sample test. Related samples. The null hypothesis is that the mean rank of all the groups are same, right? This is the null hypothesis, and we have to check the p-value of test statistic to reject the sample. If p-value is less than 0.05, reject the null hypothesis. So this is the case of Friedman ANOVA. Now I am going to show you how to apply the Friedman ANOVA. I hope now you understand where we can apply Friedman ANOVA. Clear? Okay. Go to Analyze, Non-Parametric Test, Legacy Dialogues, and here K related samples. You can see that I opt for K related samples, and we are having three outcome from the same sample, and I click on the Friedman ANOVA. So let me repeat it. Analyze, Non-Parametric Test, Legacy Dialogues, K related samples, K related samples, and send all the 3 here. Statistics, you can click on the descriptives, continue, and okay. So the mean rank of Blackboard is found to be 1.83. Mean rank of PPT is found to be 1.17, and the case study is 3. So we can say that the mean rank is found to be high in case of case study. So it may be significant. So let's see the significant. Probability value is found to be 0.000. It is based on chi-square distribution. So So 000 means the null hypothesis is rejected and the feedback in case of case study is found to be the highest. So this is the result we can draw from here, that the case study method is one of the best learning method considered in the management education. So we can draw the same conclusion, uh, that the case study method is better method, best method as compared to PPT and the blackboard. Right. So let me make a summary to you that what where we can apply which kind of test. Right. Uh, I explained you the different cases today, and let me revise once more with the help of whiteboard. So this is one of the conclusion which I am making. This is the type of test. Chi-square test. One is called Mann-Whitney test, and it is Wilcoxon is actually the substitute of it. Then we did Kruskal-Wallis test, and finally we did Friedman-ANOVA. So one thing which you should know, that what is the what we are doing here. Here we are finding out the association between two nominal variables. Here we test the mean of, here the null hypothesis, that mean rank. It is, you can write the mean rank of one group is equal to mean rank of second group. It is a substitute of t-test. Then we are having Kruskal-Wallis test. Then it means mean rank of group number 1, mean rank of group number 2, mean rank of group number 3. The same null hypothesis we have in the Friedman ANOVA, but here we are testing the mean rank of attribute 1 equal to mean rank of attribute 2 equal to mean rank of attribute 3. So here we are testing for the groups, and here we are testing for the attributes. So this is the difference, and this is the substitute of ANOVA test for independent samples, and this is the substitute of ANOVA test for repeated samples, repeated or related samples. So in short, we have conducted 4 non-parametric tests today, and I hope you have some idea of all the different tests we have done. So we are left with enough time. If you have any query, you can ask, or if you want to repeat, if you want me to repeat any exercise, I will definitely repeat that. Okay. So if there are 2 related samples, then what we do? You can apply the Mann-Whitney test in case of 2 repeated samples. So let me show you that also. If I have the repeated samples in 2 cases, so which test we can apply? So I am basically related means paired sample test. So let me check what we can apply for paired sample t-test. If I open the data for paired sample t-test, then we can check it here. Good question. T-test. Repeated means paired sample test. So this is a paired sample t-test, and open. Yeah. So we are having the pre-training score and we are having the post-training score. And we want to check whether these are different or not. Go to analyze non-parametric. Yeah, we are having two related samples, the option of two related samples. And okay, let's make the pair. So here we can apply the Wilcoxon test. So Wilcoxon test is available here and just click OK. Yeah. So we are getting the result. Yeah. So very easy. Wilcoxon test is the substitute of t-test, k related samples, and p-value here is found to be less than 0.05 and z value is more than 1.96. So null hypothesis is rejected, and mean rank. So mean rank is okay. No pre-training score
Excuse me, sir.
minus.
Sir, your screen is not visible.
Okay. Let me open it. Sorry
Okay, sir.
for
Thank you, sir.
this. Okay. So I now actually
Yeah, it's visible now, sir.
this is a example of paired sample t-test, and we are having the pre-sample example and the post-sample example, and we are comparing whether the pre-test is more than the post test or not. So if I go to the analyze the non-parametric test, legacy dialogues, and two related samples. So you are asking that what we apply in two related sample. So I just do one thing. I make a pair, send here, and in options I click on the descriptives, and I click on the Wilcoxon test, and okay. So you can see that the post-training score is 68, pre-training score is 51, and if I examine the probability value you can see is less than 0.05. So here we can say that the p-value is significant, means less than 0.05. Null hypothesis can be rejected, and we can conclude that the post-training score, which is higher than pre-training score, is significantly high. So this Wilcoxon test you can apply in case of two repeated samples. So you can, if you see the options, different options here. So we are having the mainly 5 options: 2 related samples which can be done by Mann-Whitney, K independent samples which can be done by Kruskal-Wallis. 2 related samples is applied for Wilcoxon test, and K related samples we can apply Friedman ANOVA. So these are the different non-parametric tests we have covered. And if I go to summarize, so we can compare, we can cover today the binomial test, we can compare, we covered, and all the 4 tests we have covered, and run test and binomial test we normally not applied frequently. Run test we apply to find out the randomness in the finance, right? And binomial test, I have no idea about binomial test because I never applied binomial test in any of the study. And the one sample, this is only for the I think normal distribution. We are testing whether the variables are normal distribution or not. So here you can see the test distribution is normal, and p-value is saying that the variables are normally distributed. This is an non-parametric test. Non-parametric test distribution is normal, and so I think the null hypothesis, I have to check for this. One sample Kolmogorov-Smirnov test. So what is the null hypothesis of this? I have to check. But I think they are testing whether non-parametric tests can be applied on these samples or not. This one sample Kolmogorov-Smirnov test. So now I hope you have clarity on the different tests we have covered today. Chi-square test clear. All the 4 tests we have discussed. So that's it for today. And now you can ask your query if any. You can
Sir.
unmute me. Yeah. Please.
Sir, I have a query. I have a query, sir.
Yeah, Deepika
Sir,
Das.
are you hearing me?
Yeah,
Sir,
you
are
are
you
audible.
hearing me?
Yes, you are audible completely.
Sir, in chi-square test, is there any guidelines, sir, which variable will be taken in the column and which will be in the row?
Which variable should be in the column and which variable in the row, right?
Yes, sir. Yes.
Yeah, Deepika, very good question you are asking. So basically, we are having two variables, two nominal variables, right? Suppose I'm asking you that in one example, somebody was identifying the relationship between the education of the woman and the domestic violence in the house. So now we have to find out whether the domestic violence is having an impact on the education of the woman, or education of the woman is having an impact on the domestic violence. So we have to find out which variable is independent and which variable is dependent. In almost every case, we have one line, one arrow, one-sided relationship. Here we can say that the domestic violence may depend upon the education level. So education level is independent, and its effect we can see on the dependent variable, that is domestic violence. So domestic violence should be in the column, and the first variable, which is independent, should come in the row. So normally this is the relationship we will decide, and accordingly we will put independent variable in the rows and dependent variable in the column.
Yes, sir. Thank you. I got it. Thank you, sir, once again.
Thank you. Okay, any other query?
No queries are coming, sir. So I think they have got all the points. Thank you, sir, for your nice presentation, and thank you all the participants for your patience and active participation in this session. Hope sir will come with some new topics tomorrow, and we will meet tomorrow again. Thank you once again. Thank you, sir.
Thank you.
Sir, if possible, kindly post the whiteboard presentation to me so that I can share.
Can I send you all the data set and my notes directly to you?
You told that you will share all the whiteboard presentation in the first day.
Okay, I am just sending to you. Just sending, within 1 minute you will get.
Okay. Thank you, sir.
All the data set and each and everything. And if you require, I will send also the link to download the
Materials.
link to download the Spss file.
Okay, sir. You just send it to me so that I can share.
Yeah, I'm just doing the command, sending to you, and you will get.
I will
So
share.
check your phone, and Surajit.
Yes.
So you can check your phone.
Yes.
You will receive. You received.
I got all the.
So all the notes and data set which I used for the workshop,
Okay.
I shared with you.
Okay, sir. Thank you, sir.
So thank you very much. And if anybody need SPSS, then I can also share with the one. I'm sharing one link with you.
Okay, sir.
And from this link, if anybody want, they can download the SPSS also.
Okay, sir. I will share everything with the participants.
Is anybody require SPSS or not? So I shared the SPSS 26 link with you.
Okay,
Right.
okay.
From this link, you can download the SPSS latest version of SPSS 26 without any problem.
Oh, okay, sir. Thank you, sir.
I already shared with you, Surajit.
Okay, okay. I will share it.
List of the link of the SPSS software.
Okay.
Thank you very much, sir.
Thanks.
Thank you, sir.
The network is not working properly in my place,
Yeah.
so that's why the screen.
Okay, no issues.
Okay, sir. Thank you, sir.
Thank you very much.
Thank you very much, sir. Thank you.
I request all the participants to fill up their attendance sheet. Thank you.